Hello, in this quick video we'll be reviewing the basics of vectors and their operations. This material comes from chapters 4.1 and 5.1 of your textbook. This is the material that, in my opinion, the textbook should open with. So we'll be doing this first and then proceeding more or less linearly through the textbook after this. As with most of the content that I'll be posting by video, there will be lecture notes that accompany these videos. Those lecture notes will be neater handwritten notes in PDF form. If you're in a bit of a rush, you can skim through those notes, or you can have them side by side with the video lectures, or you can review them at a later time. So let's get started. We're going to be discussing vectors in real Euclidean space. Vectors can be notated in several different ways. Sometimes I'll be putting an arrow on top of them, like V and W written here for emphasis. Your textbook uses bold. But most of the time I'm going to omit the arrow, and hopefully it'll be clear from the context that I'm talking about vectors. I have two vectors pictured here. The first is in R3 and the second is in R2. So I could be writing vectors as column vectors. So I would write something like 3, 1, 2, stacked vertically. This is a column vector. Later, I might also need to make the distinction between column vectors and row vectors. The distinction between these will come later for us, but both of them indicate the same abstract vector, which is the point 3, 1, 2 in a three-dimensional Euclidean space. So we can also use point notation, 3, 1, 2, the way you would normally denote a point in the x, y, z space. When we draw vectors, we often draw them as arrows the way they're pictured here in purple. They begin at the origin, 0, 0, 0, and they terminate with the arrowhead at the point, here 3, 1, 2. For us, in our class, we're going to primarily be looking at real vectors. So the entries, which are the numbers or mathematical objects that go inside the vector, the entries are real numbers. One could take complex numbers or some other number system, but we're going to keep things simple and primarily be using vectors. Many of our examples are going to be 2- and 3-dimensional for ease of calculation, but you can assume, unless I state otherwise, that we're dealing with real vectors. Next, let's talk about what you do with vectors. Well, one of the things that you do with vectors is you take linear combinations. A linear combination is the most basic way of taking two vectors and combining them to get a new vector. Your basic linear combination of two vectors will take the following form: CV plus DW. So in what I've written here, V and W, with the arrows on top, are vectors. C and D are what we call scalars. Scalar means it's a number. For us, numbers from the reals. And when you take this combination, it produces a new vector. So let's make this concrete with a specific example. So let's take, for example, the vector V to be 1, 1, and I'm going to use column vector notation. Let's take the vector W to be 2, 3, and let's take our scalars C to be 5 and D to be 2. If we follow the recipe that's given above, CV plus DW we'll write as 5, the scalar, times the vector 1, 1, plus 2 times the vector 2, 3. So what we need to discuss is how you do scalar multiplication and how you do vector addition. So first let's look at 5, 1 and 2 times 2, 3. So here we're going to be doing scalar multiplication. The way scalar multiplication works is the scalar multiplies times every entry in the vector. Let me write that out. Scalar multiplication. A scalar c times a vector with entries xy will look like a vector with entries c times x and c times y. The scalar multiplies everywhere. So applying that here, we're going to have two vectors, 5, 5, and then added to the next vector, which is going to be 2 times 2, so 4, and 2 times 3, which is 6. The next thing that we need to do is add these two together. This is vector addition. Because two things are happening in this linear combination, scalar multiplication and vector addition. When you have two vectors and you add them together, you add them component-wise. So if I have a vector x1, y1 and another vector x2, y2, and I've added them together, it produces a new vector with entries x1 plus x2 and y1 plus y2. So when I follow this with the example, I'm going to have 5 plus 4, which is 9, and 5 plus 6, which is 11. And this produces for me my new vector.